The question is not whether we need clean energy sources, but rather how to make a transition to cheap and reliable energy sources in the fastest possible way.
In solar energy research, computer simulations actually are a very valuable tool because they provide insight into complex physical processes in energy materials, and this insight can then be used, for instance, to design more efficient solar cells. On the other hand, it's also possible to use high-performance computing to predict the energy production of a solar plant under realistic weather conditions.
Higher resolution generally really improves our results, because with higher resolution in space and time in our models we can better resolve the natural chaos of our real-world systems. So we can better resolve the natural heterogeneity, we can better resolve the variability of fluxes and states across different space and time scales, which then improves the predictions. The cost is really the millions of core hours we have to invest in these simulations. And in EoCoE, what we try to do is we try to reduce the number of core hours we have to invest in the simulations by improving our models, which will also then reduce the power consumption of these computers to perform the simulations.
Several application codes in the energy field have not been designed for high-performance computing architectures, and they cannot exploit the computational power of these modern architectures. Therefore, they usually need restructuring in terms of programming models and techniques and tools, as well as in terms of the numerical algorithms or the numerical solvers they must use. And this is not easy, in my opinion, because of the lack of high-performance computing expertise.
The main goal of EoCoE is to create a platform, a hub, where HPC experts and the energy community can meet. And the objective of this gathering is to enhance and sharpen the performance of HPC tools dedicated to energy. Therefore, EoCoE partners can create new collaboration and develop a new technology for energy modeling, especially towards the industry and SMEs. EoCoE has decided to work in 4 energy sectors that are material for energy, to work on solar cells and also batteries and supercapacitors. We work also in meteo and wind for energy, and in water for energy with underground geothermal energy and also hydropower, and finally also in fusion, which is a long-term vision.
The most direct benefit of EoCoE is that our computational codes are really improved, and they can run very efficiently on very large supercomputing platforms, exploiting their extraordinary computational power. All scientific field in EoCoE can benefit of this coupling, optimal coupling between numerical codes and very large supercomputing.
So EoCoE is funding us to study these really exciting new type of solar cells called perovskite solar cells. And the reason they're exciting is over the last 10 years they've increased in efficiency from a few percent up to 22%, which is the same as silicon. And they're much cheaper to make than silicon, and they require much less energy to make than silicon. However, they don't last very long and they contain lead. So we're trying to use modeling of how the atoms behave to understand how to find new materials which don't suffer from these problems. And at the University of Bath, we're using a high-performance computing facility called Balena to study thousands of atoms to show the origin of these instabilities, this degradation, and to find new lead-free perovskites.
Power grid operators need uncertainties of the provided wind power and solar power. The big benefit we had from EoCoE is that we are now in a position to do this task. Before we were not able to even consider this, and now we are above this threshold to go ahead with probabilistic forecast of this size.
In the material science field, we have vectorized the molecular dynamics code called metal walls, and this allowed us to simulate electrochemical energy storage systems like supercapacitors very efficiently. In particular, we have had a gain by a factor of 5 on parallel computing architectures, and this allowed us to simulate much larger systems and to get much better insights on the physics.
Well, we have had several collaborations and different kinds of correlations. On one side, we had the collaboration with the scientists within EoCoE. For example, we interacted with the people from linear algebra that have provided us with new solvers for the linear systems. On the other hand, we have also collaborated with both big companies such as Iberdrola. In this case, it's one of the biggest wind energy producers, and we simulate the flow over a wind farm with ALIA, the code that we developed. And on the other hand, we have also collaborated with Vortex Plateless, a small and medium enterprise that is developing a new kind of wind turbine.
Maximizing the fusion performance of the future fusion reactor will require to maximize the insulating efficiency of the magnetic configuration. And it turns out that this property is mainly governed by turbulence. So as to understand, to predict and possibly to control this turbulent transport of heat, of particles, we need to rely on three-dimensional and even sometimes five-dimensional nonlinear simulations. So in this context, EoCoE allows one to save a lot of numerical resources, which amount to tens of millions of CPU hours per year, and also to run simulations in the ITER-relevant parameter range.
So we definitely made progresses. A team of domain scientists are now in contact with HPC experts and have started joint effort on a collaborative basis. The next challenge is now to adapt these scientific applications to the coming new architectures while keeping their maintainability in time. And as we speak, these new architectures are not completely known, and that's the challenge.
EoCoE has facilitated collaboration between different areas, which is very valuable. Now, to become a relevant platform, EoCoE needs to attract more HPC and energy domain experts. We need to elicit new talents and increase our collaboration of users.
EoCoE is at the crossroad of the simulation and energy transition. We have been successful in bringing together the best people in both communities, and therefore we are confident we will be able to contribute to the energy transition and foster the energy transition in Europe.